Hello everyone, welcome back to another video. Today I'll be going over solving equations, very simple equations. So basically, okay, fuck that intro. Hello everyone, welcome back to another video. Today we will be solving very simple equations. Now, the concept I'm about to show you is going to be very important. These are very simple equations to solve. But this process you will use it all throughout high school and university. It's going to become automatic to you. It has to become like addition or subtraction. If you do choose to study physics or chemistry, you will need to know how to do this. Very important. So if you haven't really been paying attention to the previous lessons, you should pay attention to this one. And if you think I don't explain it well, find another guide, but this is very important. So basically, what we want to do here is we want to solve for the variable. So in all of these equations, x is our variable. So I should probably say that. Let's just say solve for x. Just going to say solve x. So basically, we want to find out what x is in each of these equations. So starting off with the top left one, x minus 7 is equal to 8. So when you want to solve for x, right, you want to be able to isolate x. So get x by itself. Because let's just say x is equal to 6 plus 5. What is x? Simple. X is equal to 6 plus 5, which is 11, right? So if we can isolate for the x, we know what x is, right? But all of these, as you can see, x is not isolated. So we have to isolate and then solve. So getting x by itself is the hard part. Once you've done that, it gets easy. So x minus 7 is equal to 8. Well, we want to get rid of that 7. So if I want to get rid of that 7, I want to make it equal 0, right? Because x plus 0 is just going to be x. So what I want to do is, if this is minus 7, I want to add 7, because negative 7 plus 7 is 0. So let's write that out. X minus 7, I want to add 7, right? And this is equal to 8. Well, really, it's not just 8. But now look, we've added 7 on this side, because we want to get rid of the negative 7 to get x by itself, which is correct. But there's an equal sign here. This equal sign means anything on the left side is equal to anything on the right side. Therefore, anything we do on the left side must be done to the right side and vice versa. So since we added 7 on the left side, we have to add 7 on the right side too to keep the equation equal. All right? Because it's not correct to just add 7 to one side and say it's equal to the same number as it was previously. That's just not right. So now that we've done that, x minus 7 plus 7 is just 0. So we don't have to write x plus 0, it's just x, right? And now we've isolated for the x. So what's 8 plus 7? 15, right? And the good thing with these types of equations, the simple ones anyway, is you can check your answer. X is equal to 15. What's 15 minus 7? It's 8. So we know this is correct. So you can actually check your answer, which is great. So I'm just going to rewrite this bottom equation here at the top so there's more room. But yeah, pretty simple. 15x plus 5 equals 20. All right. 15x plus 5 equals 20. All right. So same process. We want to isolate for the x. And this one's a little trickier. What you want to do is, whichever numbers are not being multiplied or divided by x are the ones you want to try to get rid of first. So 15, the x is being multiplied by 15 here. So we don't really want to get rid of that right away because there's also a 5 on the same side. So it would be easier to get rid of the 5 first rather than the 15. So what I'm going to do is, if I want to get rid of 5, I want to subtract 5, because 5 minus 5 is 0. So I'll write this out as 15x plus 5 minus 5 equals 20. And again, since we're subtracting 5 on the left side, we have to do the same thing to the right side because of this equal sign. So we have to do 20 minus 5. All right? So the 5 and 5 cancel out. It's just 0. So now you can write 15x is equal to, what's 20 minus 5? It's just 15. Right? So now I want to solve for x. And now you probably already knew what x was, but I'm just going to show you how to isolate for variables as the questions get more difficult. So 15x equals 15. When you're multiplying and dividing, you can't get it to 0, but you can get it to 1. And how do I do that? 15 divided by 15 is 1. So if I do 15x and divide that by 15, 15 divided by 15 is just 1. So technically, it would be 1x. But as I've said in previous videos, the 1, you don't really write it there, because anything times 1 is just itself. So 1x is the same thing as just x. So x is equal to, we divided 15 on the left side, so we have to divide 15 on the right side. What's 15 divided by 15? 1. Right? Now, also another reason why you don't write 1x is it doesn't look right. 1x equals 1, like it's correct, but it doesn't look right. And you can actually screw up if you do that. So that's why you just write x. So let me just erase this. And again, you can check your answer. X equals 1. How can you check your answer? Well, if x is equal to 1, you just plug 1 in to the top of the original equation. So 15 times 1 is just 15, plus 5 equals 20. So we know this is correct. All right, so pretty simple. Now we're going to try another one. This one is a little more tricky. We're just increasing the difficulty as we speak. So, sorry, I just wanted to make sure it was recording. So here, a little more tricky because there's more than one variable. I mean, there's more than one number with an x in it. So when you have this type of question, x appears in more than one spot, you have to do something before you can isolate for x. And what you want to do is you want to get all of the terms with an x in it onto one side of the equation, and all of the variables without an x onto another side of the equation. All right? So if I'm looking at this, right, I could get 5x over to this side by subtracting 5x, because 5x minus 5x is 0, right? Because x can be anything, but x is also the same thing as whatever x is. So let's say x is 2, 5x minus 5x, 5 times 2, because we said x was 2, minus 5 times 2, that's 10 minus 10 equals 0. So I could do that. However, just assume I bring, this is not correct, what I'm about to do. I'm just bringing this to the side. 3x minus 5x, right? If I bring this 5 over, I'm going to get negative 2x. And it's a lot easier to deal with a positive number, especially when you're dealing with a variable in it, than it is a negative number. So because it's possible, sometimes it's not possible. When you get the more advanced equations, sometimes it's just not possible, or you don't really care because there are more complicated things you need to worry about. But right now we can make things easier. So instead of moving the 5x over, let's move the 3x over, because 5x minus 3x is 2x, positive. So what I'm going to do here is I'm going to subtract 3x from both sides. So 3x minus 3x minus 5 equals 5x plus 6 minus 3x. Anything I do on this side of the equation, I have to do to this side. So since we're subtracting 3x, I have to subtract 3x here. So the 3x cancels out. So 3x is just 0. So we're left with -5 equals, little hard to see here, but I'm going to just do the equation instead of writing it out fully, just to save time. What's 5x minus 3x? 2x. So 5x minus 3x equals 2x, and then keep the 6 in there, plus 6. All right? So now we got x to one side of the equation, but now I want to get all of the numbers without an x onto another side of the equation. So I want to get rid of this 6. How do I do that? Well, I subtract 6, because 6 minus 6 is 0. And I'm just going to rewrite this in a way that's easier to understand. -5. I'm subtracting 6 on the right side, so I have to do the same thing on the left side. So -6. So this is equal to, I'm going to just swap these, but the actual equation doesn't change. I'm just rewriting it differently. So 2x is equal to -5 minus 6. Same equation, I just put the 2x on this side, -5 minus 6 on the other side. I'm not doing anything. It's like saying 1 plus 2 is the same thing as 2 plus 1. It's the same thing, all right? Don't worry about me switching it. So 2x equals -5 minus 6. So I want to solve for this. I want to perform the equation. So 2x equals -5 minus 6 is -11. Right? And now I want to isolate for the x. So since it's being multiplied by 2 right now, I want to divide by 2. So since I'm dividing by 2 on the left side, I have to do the same thing to the right side. So -11 divided by 2. So therefore, x is equal to, typically, when you're doing your tests and stuff, your teacher is probably going to want you to put this in, your teacher is probably going to want to make sure that you put this in the fraction form, so just keep it as it is. So this can be written as -11 divided by 2. You can put the negative on the side directly if you want. But if you do want to put it into a decimal or a number, it's technically not wrong. Let's just put this up here. X is equal to -11 divided by 2 is, I'm going to put an arrow down here because I have enough room, -5.5. So that's the answer. So either -11 over 2 or -5.5 is what x is, same thing. So I'm not going to do this because I don't have the brain power to check an answer with a decimal in it, but if you want to, you can plug in -5.5 in for x and see if this side of the equation equals this side. So what you would do is 3 times -5.5 minus 5, write the answer for that, and then do 5 times -5.5 plus 6. The answer should be the same. So I will be going over more types of these questions. I will increase the difficulty, and I'm doing that because this concept is very important. So yeah.